I think you guys can see my screen, right?
Yes. Let me show you this.
Yes, I can.
Okay. Start then. I'll also look at the time too. Okay. So let's design a system that takes readings from a large number of temperature sensors that's sprinkled throughout, let's say, a geographic area. Let's say the state of Washington. So, and you would like to present a couple of views of that data. So let's say Washington is about 100,000 square miles. Let's say we have 1,000,000 sensors, and that should be enough to cover, a good resolution of the area. And what we want from like the output of it is we would like to present like a bitmap, a representation of the temperature. And for now, we basically have two use cases. One is, get the latest temperature, we want to show that. And then also get the historical. For now, we can focus on the daily, weekly, and monthly.
Sure. So just to confirm again, so this is just for Washington, right? It is not kind of that we are creating something global.
Yes, good. Yes, yeah. Let's
Right.
focus on Washington State.
And then who will be the consumers of this data? Like, when we show a bitmap or a heat map of this temperature, so who all are going to view this data?
Yeah. So let's say that we will pull that bitmap into a web-based UI. Like if we map each data point to like a single pixel, so let's say 1,000,000, it should fit a 4K screen. So that's kind of, and you don't need to worry about interpolation. So let's start from there.
Sure. So the number of sensors are 1,000,000 sensors, and then so these 1,000,000 sensors, like what is the frequency we are thinking about that they'll be pushing the data?
Yeah, good question. So now for now let's look at 10 seconds. Okay. And then also for the requirement B, let's get we can scope it down to just the min and max for the daily, weekly, and monthly. Yeah.
Sure. And these are the sensors, like who will be writing the data. But then when we say that we'll be showing it on a UI, so how many users do we have, like the daily active users who will be viewing this data?
Yeah, so for now there's no let's see here. So for this case, how many views? So let's say that the TPS is going to be low. You can say it's only around probably 15 to 20,000 calls. But let's say it's gonna be like a web-based UI. But if you want, like if we can go at a lower scale, but we should plan to support around 15 to 20,000. Oh, yeah, 15 to 20. Sorry.
This is 20K TPS, right, per second.
Oh yeah, I meant so I think I misspoke. 15 to 20.
Okay, 50 to 20. Okay, that's fine.
Oh,
20 to 50, right?
15.
Only 20 to 50.
Oh, 15. Sorry.
Okay.
15 to 20. Yeah.
And then if we talk about the CAP theorem, consistency, availability, and partition tolerance. So since this is based on a lot of sensors, so we have to take into consideration the partitioning, like the network delays and network breaks. So what do we consider more important, whether it is availability or consistency? And by consistency, I mean it is not that the temperature, there is a vast variance, but then by consistency I mean that a sensor is pushing in the data, so it might be available, say not within 10 seconds, but then by 15 seconds, eventual consistent, right? But then for availability, I mean at least the heat map should be showing something, right?
Yes, so definitely
kind of a near real time.
Yeah, yes. So definitely for the reads, you would like this to be available.
Mm-hmm.
For the consistency slash freshness, I would actually leave that to you.
Sure,
See if we can have some wiggle room in there.
sure.
Okay, MindPixel, you
Mm-hmm.
can essentially make this full screen, so it'll be easier for you to.
Okay. Actually, this is
Yeah,
the first time I'm using it. Like, how do I make it full screen?
you can actually from the Chrome window, you
Mm-hmm.
can just click on the double dot and then say full screen. Mm,
I think from the Chrome menu on top of your laptop in the View tab, in the
You
View
try
menu,
F1. I think it's Chrome, so F1 might work.
Command F, Shift Command F.
Somehow it's not.
F11. No, it is F11.
F11. Sorry, F11.
Better now?
yeah.
Yes.
Cool. So I think we we are fine with the requirements. We have basically, like, for the MVP, we have two requirements. One is to get the latest temperature, and then once we are done with it, we'll talk about the historical temperatures based on daily, weekly, and monthly. That too, just the minimum and the maximum, right?
Yes,
I-
yes.
right. So we'll be designing the system for that, and then we'll be going for near real time, and for eventual consistency, we'll be discussing the freshness, like, as we move forward. Now going into the API design. So first API will be to ingest the temperatures, right? And for ingesting the data, like, the first parameter which I'll be taking it in is the sensor ID. Then the temperature, then the time at which the data was inserted. Uh, is it okay, like, or do you think we need something more?
So for this, how would you determine on the location? Like, would there be would the location be is the location the responsibility of the
I mean,
sensor, or do you want to
yes, I
handle
mean,
that
sorry,
elsewhere?
like, yeah, that was my assumption that the sensors are kind of permanently fixed, but then yes, they can be, in transit, like on some other vehicle or anything. So yes, we can even capture the coordinates.
Oh yeah, so I wasn't pushing for that. I was just wondering, like if the lat
Because
long is part of
if
the
it is a
input,
fixed
or
sensor, then it is already registered in our system, and we know that
okay.
from which location it is coming. So I don't want to increase the bandwidth for no
Yep, that
reason.
makes
But
sense.
then if you
Mhm.
are, like, if you want to make it variable, then we can capture.
Oh no, I think let's go with your first assumption. Yeah.
Sure. So first API will be the ingest data, and then the next API will be to get the temperature, right? And when we say get stats, so it will be pulling in the whole, that bitmap for 1 million sensors, right?
So yes, so it can be
Or we
like
can query for some
if you want to go
specific
that route.
sensor or some specific region.
Yeah, but I think at a high level though, you're right. Like it could be like it's like an Uber API, like get stats for like
Sure. And
or
we'll be
Washington.
just passing, the time frame from when till when we want to see, like, whether if it is a real time, in that case, the from and to will be the same. And in case of the daily, weekly, or monthly, or we can put it as a type, right? Interval type.
Okay. Are you thinking about this API will be used by both the latest temp and the historical temp?
I think the front, like the facing API can be same, but then internally we will have to make a different system for both of them. So initially, let's keep it as same, and then when we go into the deep dive, we'll talk about how we will separate these two, right?
Okay, that sounds good.
Fine. Then moving to the high level design. So these are the various, first of all, I'm talking about the first API, which is the ingest data. So these are various sensors which are sitting around the state. They'll be talking to, since there are 1 million, the write throughput is 1 million, and it is every 10 seconds. So for 1 second, it is 100K writes which we are getting, right? So for 100K writes, I would prefer using a queue in between so that we do not lose any data or we do not overwhelm our systems. So first of all, when these clients or when these sensors ingest the data, it will directly go into a queue. And in front will be sitting our API gateway. And then from the queue, it will be pulled or consumed by different services. And then the ingestion service persists the data in a database. What kind of database we will be using? I'll be talking that in a deep dive. Right now, I'm just creating a very basic vanilla flavor so that we are clear with the requirements and we make sure that we cover all of the asks. And then for consumers, they'll again be sending their request to the API gateway. API gateway will forward their request to the query engine. So we will be having two different services for scalability. Like one will be the real-time service from which you can pull in the latest temperature heat map, whereas we'll have another service to aggregate the data. Like if you want it based on hour or a day. Internally, where both will be talking to the database. So now there can be different mechanisms, whether you want to go for a push model or a pull model. So even that, I think we'll be discussing in the deep dive. So I'll just make out few points like which I feel are important and we can talk during the deep dive. So these are the four things which I feel are important. Like one is the push model, the real time, pull model for the aggregate data, why we are using a queue for reliability. Like, if you want, we can discuss further. And then the choice of database for this time series data. So do you think there are any more topics which you want to cover in the deep dive?
Yeah, I think yeah, let's start with what you have. And then after that, I'm also curious to know about like I know you talk about the reliability of the queue. Maybe if we have time we can go over the reliability of each piece that you have in here. But I
Sure.
think this
And
goes.
are you good with the high level design? Like, or do you have any concerns or anything?
I think these are good high level blocks that I understand. Yeah.
Sure. uh, After the high level, like, I would like to create the schema. Like, we have basically two places where we'll be having the schema. One is the queue and other is the database, right? So for the queue, the schema will be something like the sensor ID, temperature, and the timestamp. And for the database, the schema will be something like okay. Now considering 8 bytes for sensor ID, again the temperature to be maximum, like 8 bytes, and the timestamp as 8 bytes. So considering this as 30 bytes for the queue, so queue will be having 30 bytes for one record, and per second I'm getting 100K, right? So 100K into 30 bytes. So this is 3 MB data per second, which the queue will be holding from 1 million sensors.
I got a question. So, quick
Mhm.
question. So for the earlier, when the clients are pushing the, the temperature,
Mhm.
I'm curious, or and let me know if this is going to be covered later. Like, I'm curious, where does the location will be stored? Um,
The like from which location it is coming?
because on
Yes.
the bitmap we would need to map it. If it's gonna be handled later on.
No, that's
Sorry.
absolutely fine. I missed that point. So it'll be a separate service wherein whenever a new sensor gets registered, right? So we put in, like, which location it is present. So we will have one more schema, and that is the sensor ID location, and location will be latitude and longitude. And then installation time, like, when it was set up at that particular location. So it is around 35 bytes. This one is also 30 bytes. And this one is 35 bytes. And this data will be almost constant since we have 1 million sensors installed at a particular point of time. Now we'll be increasing it and assuming the increased volume as 10% per year, right? So for 1 year, my this sensor information uh, data will be 1 million into 30 bytes. So that is 30 MB per year. And if I say that the increase is around 10%, so that is 3 MBs per year, right? And if you want to store, say, 10 years of data, so that will be around 10. So maximum it will reach to around 500 MBs, right? So this data is pretty small and we can easily save it in a SQL database so that later on, like, when we want to query that for this particular sensor ID, what is the location, we can easily pull it out. Then we were talking about the queue. So for queue per second rate of data ingestion is 3 MB, 3 megabytes. And suppose we hold the data for 10 seconds in the queue, right? So maximum it will reach to around 30 MBs.
Oh, so this is another 10 seconds of on top of the 10 seconds.
Yes, actually,
by
I thought
sensor,
of coming
okay.
it in the deep dive, like on this 10 seconds. So what I'm like for the even for the real time, remember I said that when you pull in the data, there will be eventual consistency and it will be showing, say, 10 seconds is back data, correct? It will not be exactly real time. It will be kind of near real time, right? So
Okay.
yeah. Yeah, and then if I talk about the scale of the database, so for database, again, it is 30 bytes. And we will be having 1 million records. Or let's take it as 100K only for per second, assuming we'll be ingesting every record into the database, right? So this is per second. So in a day, we will have around so these many metrics we'll be having, and this is around 3 GBs of data per day in the database, right? And assuming like, we maximum like, we need it for 5 years. So for 5 years, this will be so approximately this is 450 GBs. Regarding like, how do we store it? Like, how do we maintain the database? We'll come at a later point. So I just wanted to go through this design again to see that, we are covering all the requirements. So we wanted to design a temperature sensor collection system. Also, we wanted to represent a bitmap as output, show it in a web-based UI, get the latest temperature, get the historical temperature daily, weekly, and monthly, just the minimum and the maximum. 1 million sensors are there, area is this much, writes every 10 seconds.
I have can you talk about like, so we decided on like the push model. Can you briefly talk about like the if you considered also the pull model, and what's the advantage of each, like push
Yes,
and pull?
I have like, noted on both of them, the push and the pull
Okay.
model. Yeah, let's go to the deep dive. So first of all, you want to talk about the push and the pull model, right? So my thought process was for real time, every time if we keep on pulling the data. So for pulling, like we'll have to pull when the new fresh data is available. So that will overwhelm our database. I mean, we won't be able to handle that much traffic, because if we look at it, we have the TPS is as 15 to 20K per second, right? So we have 20K reads per second, and that will be quite overwhelming for the database to handle that many connections. So better is like, for such a high number of reads, if we introduce a cache in front, and then as and when new data is available, we just put it into the cache. And when required, whenever like we want to refresh the heat map, we can just pull the data from this heat map, right? So that will be
Okay.
based on the pull mechanism. And the push mechanism is, suppose we are aggregating, like, we do not want to be exactly real time. Like if we persist the data for every second, in that case, like it'll be a lot of data. What if we, create a window of 10 seconds, right? And we aggregate that data just to give us some window of in case we lose some of the data points. So we aggregate that 10 seconds data and put it into the database, kind of an average of the temperature of 10 seconds.
Got it. Okay. For the push when pushing,
Mhm.
how will we make sure that our API gateway and then our queue
Mhm.
is scalable with the amount of incoming data? And then a follow-up to that is so I think the discussion on push and pull makes sense. How would you account for like if a sensor is dead?
Mhm.
I'm curious to hear your thoughts on that.
Okay. So I think like when we say how will we take care of the scale with the API gateway and the queue. So I think in that case we will have to kind of split it or shard it based on the geography, like from where it is coming, right? Because all of the data coming to a single API gateway, that will kind of create a bottleneck. So instead of that, we will be creating multiple API gateways, kind of active and passive. And in case one API gateway goes down, we have something in the background to take care of that. Now, if we talk about the queue, we can split the data based on the location from where it is coming, right? So instead of a single queue, we can create a hierarchical structure wherein uh, not a hierarchical structure, but then we can split it based on the region. So suppose from east, west, north, and south, we can create 4 different queues to distribute the traffic accordingly, right?
Right.
I
Yep.
hope
Okay.
that's fine.
Yep. That makes sense. Yeah.
Yeah. And then you were talking about in case a sensor goes down.
Mm-hmm. Yes, because we're already waiting 10 seconds and we are doing another 10 seconds. I think those are okay.
Mhm.
But I guess how would we deal with um, a dead sensor? Like if a sensor is not healthy anymore.
Right. So if a sensor is not healthy anymore, so assuming there are 1 million sensors, so by the time, like, since these are hardware devices and we need to replace it since it's already dead. So assuming it takes a day to replace that sensor, so we will still rely on the nearby sensors, like, the sensors which are very nearby to this particular sensor, which is dead, correct? And then we'll look at the historical pattern of this sensor along with the other sensors which are nearby to it, like how much delta there was. And accordingly, we'll calculate it ourselves and push it into the database. Does that sound fair enough?
Okay, so we would interpolate like
Yes, we
what
would
was missing.
interpolate. Yeah.
Okay.
One thing I also
Okay.
wanted to cover here was the timestamp. Like, the timestamp is an
Yeah.
important aspect. So which timestamp would we consider? The sensor's timestamp or the system timestamp, correct?
Mm-hmm. Mm-hmm.
For the timestamp, I think like there are two approaches. One is the sensor timestamp, but then is so the pro of this will be like, it will be very accurate. We'll get the time when the data was sent, but then there can be some issue, some technical issue with the sensor, and it might not send the correct timestamp, correct? Suppose it clocks moves 1 hour back. So we won't be getting the exact correct timestamp, right? And another option we have for the time is if we take the server timestamp. So in this case, the pro is uh, we will have a better control. over the security of the timestamp. But then we'll have to do with the network delays. It won't be the exactly real time kind of a thing, right?
Mhm.
So with these two options, I think it's still better to go with the server timestamp at least, so that we have better control over the security and the network delays, since we are considering only a single region, Washington, right?
Okay.
So the network delay will be maximum, I think, not more than 100 milliseconds, correct?
Yeah, I think this makes sense. Can we, I think we have, I'm not sure how much time. Can we go over I'm curious about the storage and then the query
Sure,
on basically and end to end. Like
sure.
what's the query look like?
Okay, so first of all, talking about the storage. So this is, since this is a time series database, so I would prefer a time series database wherein we have a lot of inserts, and the inserts are basically like for fast inserts, I'll prefer using an LSM LSM engine, wherein it just keeps on dumping the data into the wall along with the other data structure. Like if we talk about Cassandra, so it will be kind of a wall along with the mem table, right? And then for retrieving of the data, I prefer using an aggregate service in between. So here, if you look like, from the queue, there was this ingestion service which was pulling in the data. So when this ingestion service pulls in the data, instead of pushing every seconds record into the database, like we have two options: either we push every seconds data into the database, or we aggregate it. We aggregate 10 seconds data and then push the metrics into the database. Why I say pushing every 10 seconds data into the database, so that we cope up with the traffic, because 1 million records per second, like, that is really huge. So I don't want to overwhelm the system. So depending upon the requirements, like the trade-offs, we can decide whether we want to push all of the records into the database or aggregate it. Assuming right now we are going ahead with pushing all of the data into the database. So every time, like per second, we'll be inserting 100K records. So that's why for 100K records, I say we'll be going with a time series database which will be using the LSM engine. And then with time series database, we do have the benefit of, the fields and the tags, wherein suppose if I want to query based on the timestamp. So for timestamp, I can use a where clause. I'll put the time as my field. And then if you want to look for specific locations, so the locations will be my tags. So we can group it so that for particular East region during this time frame, what was the temperature, right? So we can perform various analytics based on the user's choice. Moreover, we want to provide reliability, and with so much of data, I think it's better to replicate it, so that in case one system goes down, we do have another system to take up the load, right? So in this one, since we initially said in the non-functional requirements that we will be doing away with consistency, that we want to go ahead with eventual consistency and we want to be highly available. So I prefer going for a leaderless architecture. Since our aim here is to ingest the data first, and then we can do the reconciliation in the background. So this was all about the writes, the high volume of the writes. Now, if I talk about the reads, so with 15 to 20K reads per second. So these reads are pretty high for a single machine. I mean, a single machine can handle, but still uh, these are high. So how will I handle these 15, 20Ks per second?
Yes, let's also, so for the reads, let's not forget that we're also calling for each of those sensors. So we're asking for the reads for the million sensors.
Right. So we'll be calling the basic vanilla read API, wherein we just
Mhm.
say, give me the stats, and it'll pull in all the 1 million records and show it on the heat map, right? So in that case, what I'll prefer is when the system starts up means like, we have, assuming we already have a heat map created from the last second, correct? So instead of pulling all the data points again and again, I'll prefer like, just pulling in the delta. If the temperature varies, say like, plus minus zero point 0.5, then only I'll be pulling in the data. Otherwise, I prefer to keep the heat map as it is. Otherwise, with refreshing that heat map every second with 1 million records, like, it'll stall the system.
Oh, I missed the part. Well, um, so how do we know there's a delta?
uh, since we have this aggregate service and we are pushing the data for every second into the database, right?
Mhm.
So when we have this push and the pull mechanism, so while pushing, we will there will be a service which will see that, for this particular second I have this data for this particular sensor, and the previous second it was this much temperature. If there is a difference, then only it pushes the data. Otherwise, it just ignores that value.
Okay, so on the, I guess on the application side, it's
Mhm.
listening to a change by the aggregate.
Yes. So when the ingestion service puts the data into the database, before pushing it, like we'll have one more service here. Let's call it as the aggregator service, right? So this service, it pulls the data from the database, and every time, like, so for it pulls the data for all the 1 million sensors, say every second. So every second it compares with the previous readings and see what is the delta for each sensor, and accordingly pushes it forward to the real-time service to instead of
Got it.
refreshing the whole heat map, just refresh the parts wherein like there is a significant difference in the temperature recordings,
Okay. Okay.
right? So we were talking about like the database storage. So are you fine with this approach, or you want me to cover any other aspect for the database storage?
Oh, so my question is more on the query side. I think we have like 5 minutes left, but maybe you can talk about the query. Like, so I'm curious. I'm curious on. So let's say, um, there is an update for worst case scenario. There's an update for all the million sensors. Um, do we plan to fetch all of the, basically make a million calls? Because our database is sharded, right? Like you
Right.
mentioned.
Yes.
So so for each of those database, let's say there's like 1,000 shards in there.
Hmm.
Like, do we plan to do that? And then my question after that is, what if there's like a slow database? Uh, what should we do? Like, if one of them
Hmm.
fails, or yeah.
Right, right. So in case one of the database fails, we will be having a replication factor, assuming the replication factor is 3. So even if a database fails, we still have the copy of the data in some other node, right? So with the leaderless
Oh yeah, yeah.
architect,
Sorry. Yeah, I mean, the call to the database. Like,
okay.
so let's say, hey, I'm refreshing this map. I
Hmm.
have 1,000 of databases to call.
Hmm.
So how would we take into account the slow calls to the database? Let's
Okay.
say we want like the hard refresh to be around 2 seconds or so.
Okay. So for every 2 seconds, like, there will be a call to all of the databases to pull the data. So I think instead of calling the database directly, when we have the aggregator service, we will have multiple versions of this aggregator service. Say each aggregator service connects to 5 databases, right? So we will
Mhm,
be having
mhm.
these 20 aggregator service. These 20 aggregator service calls are 1,000 databases. And then these aggregator services decide like, which data to push forward. So that's how we will be splitting our load. Instead of 1,000 calls, we'll just make it as 20, right?
Okay. Okay.
Yeah. We are done with the database choice, pull model, push model. Like one more thing which I wanted to cover was the queue reliability. I mean, like if we have time, I'm fine. Otherwise, like what do you suggest?
Um, can you can we dig a little bit more on? Can you scroll down on the storage?
Mhm.
Like so in here, can you go maybe on the schema on like the read? So you mentioned we're gonna use a time series, right? So
Right.
is that for both historicals and also for the get live?
For historical, I think like we can use a batch job for that because we only need the maximum and the minimum values, right? So there are two options for calculating the maximum and the minimum. So they can be a batch job which we can easily configure. So if you look at it, we had three options. One was daily, weekly, and monthly. So for daily, we calculate the minimum and the maximum temperature. And for all the days, like, we just take an average of that and we use it as the minimum and maximum for that particular week. And then we take the average of 4 weeks and take it as monthly, correct? So creating a
Okay.
batch job in parallel, I think that should be more than sufficient to solve this use case, right?
Okay, and
Uh,
this will and this will handle the historicals.
yes.
Got it. And then I guess here we can just assume that there is some function that you know that will decide which is the value for daily or which is the value for weekly and monthly.
Yeah, I mean, like we will be keeping it in the database that, for this particular day, what was the maximum and what was the minimum temperature.
Okay. Okay.
Or if I can think about like, instead of putting this thing, a batch job, we can just like if we want to create an algorithm, we'll just whenever we insert anything into the database, at that time only we can see if it is less than the minimum or if it is more than the maximum. We just change our minimum and maximum for that particular day. So my aim here is just to take care of the minimum and maximum for a particular day. Once we have that, we can easily do it for the particular week and the month, even though there might
Is
be outliers, but then I feel like that is the perfect strategy to calculate the minimum and the maximum.
is the minimum and maximum per each device or per for the whole region?
So right now I'm taking it as per region. So east, west, north, south, but then that can be aggregated and, done based on that the whole region. Or if you, or do you want it like, per device, the minimum and the maximum?
Oh no, no, I think it's good. Like if uh
Uh,
I would start for the whole region.
yeah, I thought it like, just to split it based on the four regions initially, and then, just combine it for the whole region, like just average it out.
Okay. So I know I think we're closer to 40, but last question, like if we were to extend this to let's say you want a min-max reading for an arbitrary period. So I know we said okay, let's do it a daily, weekly, monthly, but let's say like you go like for a specific hour to a second within a 10-second resolution, right?
Mhm.
Curious on how would we extend the design?
So if you want to get the maximum and minimum for a particular time frame, say from 2 p.m. to 3 p.m., right, for that particular hour, in that case, one option is just to go into the database and query. So it depends upon the use case. If we have a lot of such requests, in that case, we need to design a separate service which helps us doing that. In case like, it is kind of one of a request, then it doesn't hurt to just directly go into the database and fire the query, right?
Any change on your schema or the way you would aggregate it?
I mean, we are already aggregating it, like we are already dumping the data for per second.
Got it. Okay. So you would have a per second per
Yes. So when we will
per
fire the
device.
where clause, so it will be, going directly into that particular 1 hour window and doing the aggregation. So that is kind of a brute force thing. But then if I want to update my schema for this particular use case, what I can do is like in this aggregator service, I can just make it extensible wherein if I spin up another service, another version of this aggregation service, and which calculates it for 1 hour for me. I want to pre-calculate so that I'm able to respond back to the user as fast as possible with low latency. So that is why I said, it all depends upon our use case. If it is one of a call, then I'll prefer the request to directly go into the database, right? At runtime, just calculate it. Else, if it is a very frequently used use case, then it's better to create a new aggregation service. But then changing the schema, I do not think that is a good option. Why? Because today we have a use case of 1 hour, but then tomorrow we can say it is not a hard code kind of a thing that every time we'll be getting it as 1 hour. You might get a use case wherein the user say, give me the data for 2 hours or something like that. So instead of making changes in the schema, it's better to create a service which takes this parameter, like what all are the different patterns user are querying, and then make it smart enough to pre-calculate this data.
Okay. Yep, that makes sense. I think we're out of time. I'm gonna compile my notes and leave the mic to everybody. And of course, thank you.
Thanks, guys.
Yeah, I think the interviewer wants us to start asking questions while he's recollecting and writing down his feedback. If anybody else has any question, please shoot.
I think not a question, but then my for one day or like say for example last 2 days of data, I think that can be put in the cache if because let's say those are the frequent queries that we get, and since the data is not huge, I think if we just put 1 2 days of data, or at least say one day within one day, that should be able to take the load instead of hitting the database. That's one thing I think I would probably I was thinking that can be done. Just
Yes,
for
I agree.
yeah. And one other thing I was thinking is even this data, the caching can be the choice for the cache. I was thinking since one day has how many, like 1440 seconds?
86400.
Sorry, 86400 seconds and 1440 minutes. Probably we can use a ring buffer kind of a thing wherein it can easily replace, like say for example, every minute if it is every minute, I was thinking like a ring buffer, if we have that to update, right? How are we going to update the cache? Say for example, if you are storing like one day of data, how are we going to update the cache? So wondering, ring buffer is the one wherein we know this dedicated key is for this particular probably seconds, or like in this case it is 10 seconds we would need, right?
Mm-hmm.
Okay, yeah, that would be like whatever number of keys. That way we have we don't have to worry about how to evict the cache, right?
Okay.
I was wondering, I have used for another design for stream processing wherein we get these events, right? Just like the sensors. So ring buffer was one of the choice that I had to make. And how did we arrive that 100K requests per second? We said 1 million sensors.
So 1
And
million sensors, and we said that there was this aggregation of 10 seconds, writes every 10
every 10
seconds.
seconds.
Yeah. So for
Mm-hmm.
each second, we thought that, it will be 100K.
Hmm. Got it. And yeah, one other thing, time series database also supports this sharding or by like say time, not time, so that we can easily archive and then just what you call archive the say we wanted to maintain only 1 month of data. We
Mm-hmm.
can quickly drop the partitions which are like older, so that the historical data and everything is taken care in the archival database, and we have only 1 month of active data, operational data in the operational database, right? I think time series database provides a way wherein we can just drop in older data. I'm not sure if anyone has worked on
I'm
it,
not
but
aware
even
of it. Like I
yeah,
have used time series
What do you
database, but
mean?
then in our case, like the data was not that huge.
What do you mean about dropping? You're talking about resolution, or you're talking about
say for ex-
hierarchical storage?
so
Moving
this
it to some like cold storage that we don't
correct,
need it that frequently. So just
Okay,
to
yeah.
yeah, because our
save some cost.
There's
because our
another thing
sensors are
that
permanent.
that
Sorry,
it could be one of the case for time series is the resolution, right? So maybe you have the resolution of 1 second. If you want to actually do some queries that are historical, you can lower the resolution.
Yeah.
That's
Yeah,
another
that is
problem.
a better option. Yeah.
I think Z had comments while the interview was happening, and then even before that. If you want to look through the mind pixel.
think
Yeah,
he
I've just
said,
opened up the chat.
can we partition the database by sensor ID to reduce the number of writes? One question is that I see.
Yeah, so I'll actually go with the question. So you mentioned that you need to aggregate before writing to the database, right? So if you consider database as a single entity, then there is a large number of writes. If you did partition it by sensor ID, then you can essentially have all the writes for a particular sensor go to a particular partition, which reduces the write a lot. So I don't know whether you need to do anything special to reduce the amount of load coming into the database.
Yeah, and I just wanted to evolve that idea. Like if you're pre-aggregating, also there has to be some sort of maybe there are multiple ways to do that, but if you are doing this in a stream processing fashion, you might need to have consumers that is holding your fixed window that you're trying to aggregate. So that implies more complexity on those stream processors as well. So that's something.
Yeah, I agree to that as well. Like I mean, the lesser aggregation that you do, the better it is. And if you are using a database like Cassandra, which supports partitioning natively, I don't see a reason for aggregation, pre-aggregation before writes. Yeah, the next one was you mentioned that in the API gateways you will have an active passive kind of a model, but what I mean, like it's probably not necessary because the gateways are stateless. The only thing that they need to do is to actually like route it to some database or do something, or route it to something that is stateful. So I don't think you need an active passive one here. Uh, when as long as you have a service discovery system that will help you route the request to the right API gateway, it should be good.
So my
In some
assumption is
cases,
that the service discovery resides inside the API gateway. I might be wrong. So my thought process was like, in case the API gateway goes down due to so many issues. So like I have a lot of incoming data and I do not want to lose that. losing say for 10 or 15 seconds, that's absolutely fine, but then I don't want to lose it further. So that's why I said that, to have it an active passive kind of a thing, that in case the active one goes down, I do have something sitting at the back which can quickly come up and take up the load, right? But then yes, like it is all stateless kind of a thing. Like it's not something which is that, it'll be coming up and taking care of some of the in-flight data, because the in-flight data that is lost, like, say for 5 seconds.
Yeah, so regardless of this, right, like yeah, if you have an active passive system, there is going to be some sort of a downtime, because once your active thing goes down, there is a slight delay before the passive actually becomes an active. So there is anyway a slight delay. You might actually use, I mean, like there's anyway a slight delay. So the problem is not getting solved there.
Okay.
So in that we can scale API based on the health checks, because it will be a machine only. Or we'll be using any managed API gateway like AWS API gateway or the Azure one.
Yeah, if we are
Because we
using an
just need to
AWS
replace the
managed
gateway.
gateway, yeah, if we are using an AWS managed gateway, I don't think like we'll have to talk about active passive here, because that's
Yeah,
AWS's
because they
responsibility to
can scale to
do that properly.
scale to million. Also can't if we need to reduce the load on the gateway, we can have multiple gateway in
Yeah.
parallel based on the what is on a sensors. So we can divide the sensors. Then a certain number of sensor can send traffic to a specific gateway. To reduce the traffic on that gateway. In that way, we don't need to actually start the queue also.
Right. But then if you think about it, like, the gateway is not doing not doing much. It is just taking in the request and then seeing whether it is a read or a write, and then accordingly routing it. So, I mean, I do not know how much helpful it will be to even shard based on, the type of request. Moreover, how do we take care that a particular request coming from east zone goes to the gateway taking care of east zone requests? Again, we'll have to introduce something in before that, correct?
Yeah, how will you identify? Yeah, correct. That the sensor will go to which gateway.
Also, one view for IoT application. This is I'm kind of uh, comparing this with like an IoT kind of an application wherein the sensors are just sending those events, and then we have to support real-time analytics versus historical. For usually these kind of systems, there is also streaming application architecture that we can follow, right? When we can stream for the real time, we can apply the stream application architecture, and for historical, we can use the big data or the batch processing, the one that I think you covered. But for real time, I think streaming application does whatever we want for real time. So probably that's.
Yes. So
I
just
don't know.
wanted to ask the group, like, yesterday I was studying, and this is what is called as Lambda architecture, that, you have these two processes running in parallel doing the same thing, but then one is fast and the other is slow. So, I mean, is it what it is? Because I haven't like worked with this Lambda
Um,
architecture.
Batch processing more for
You mean then Lambda
like for
functions,
example.
AWS Lambda functions, or serverless
No, it
functions?
said that this is what you call as Lambda architecture, that when you have two flows for the same thing, one flow is taking care of the real-time processing, the stream processing, and another flow is taking care of batch. It is a slow thing.
So batch
So,
processing can be like not just it can not only do the average or min max, anything that you would want to have as analytics, right? It can
mhm.
be say, I don't know, within Washington, you would want to do particular city um, I don't know what example can I give here, but say another kind of example for average, min, max, for events that are getting published in every second, right?
Mm-hmm.
And there are like millions of events. Also, in it's not just here. We are talking about very less data, right? And imagine there's a huge data wherein we have to go across. Okay, get me top 10 movies that were watched on Netflix for last 1 month. So the data is huge. So and if we have to get the historical analytics like monthly, I think batch processing system supports, works very well there.
Right.
But for real time, like within a day or two, is what streaming application is something we would have to
So
use.
when we say streaming applications, like what extra do we need to mention in the interview? Like, we have this queue, we have this aggregator service, like what extra is there in this stream processing?
I mean, just that the streaming technologies there are like Apache Spark
Okay,
and
Fling.
Flink, yeah, and for the big data, Hadoop and those.
Sure.
Yeah. Just one learning that I had. I have mentioned time series database in one of the interview that I have given. The interviewer asked like which database would you use and all that questions. I had stumbled a belt. I, I knew there are like multiple, but which one would suit more, right? Um, I talked about I think Apache, Druid, and InfluxDB, and he wanted examples in that interview. That was something new for me. Usually we say we should not will not be taking names of the technologies, but there could be some interviewers might be asking about
Right.
these names too. Yeah.
But then it depends upon the scale you have worked. Like,
Correct.
I said time series database because I have used it and I've used this InfluxDB, but then not on a very big scale. It was on a very
Mm,
small scale, like, for one, you can say program, and there were a few projects inside that, and we were collecting the metrics inside that. But it wasn't
mhm.
that too huge that, we have to shard it or things like that. It was a single instance that was spinned up.
Got it.
One of the things that it's worth to pay attention there is that if you're talking about a push model, InfluxDB and probably Apache Druid would fit well. But if you're trying to actually talk like about Prometheus, maybe this is more like for pull model. So there are differences there. And it remind me something about what you said about registering the devices. So once you're in a pool model, you probably need some sort of service discovery to actually reach out to the sensors. And once you do that, you kind of don't need to actually keep that registration because the labels are being already in your pull model mechanism. So essentially you're pulling only the timestamp and value in a pull model. And they know because of the labels that you push into your service discovery layer, what sensors you're talking about. So. There is a point of discussion here as well. Like, I think that one of the key things about this question is the fact that we are looking to get deltas. So I'm wondering if this could be also a point of discussion for the interviewer, if we can say like, can we introduce something in the sensors that would only send deltas? I think that it could actually minimize the amount of data that is being passed out to the backend.
Yes, I feel like that is a good option, but then there is one downside of it, that in case someone hacks the sensors and they try to send, right, something nasty. In that case, we need to have an extra system to take care of these issues, right?
But that would be the same for you sending the data as well. So I can be a bad actor sending bad data. I don't feel how it's different.
Yep, fair enough.
Um, you mentioned about pull also, right, as an option. Where did we use where did we discuss the pull for? I know push is like every 10 seconds. Aggregated data is something we are pushing to the database, but
So pull is
how
like,
is
when you want to pull it, say for
okay?
the daily, or like, wherein
Got it.
you have, yeah.
Okay.
Okay,
Aggregation service or
can
custom
you
service would
expand on that? Because like what I understand of the pull model is really like getting a system that can actually reach out to the sensors and pulling the data from the defined time that you want. Like, for example, this is how Prometheus works, by the way. Like you define your service, like your sensors, and then it gets registered, for example, in a service discovery. And then in the time that you specified, the time interval, the Prometheus scraper would actually go there and get the data from it. So basically, that's why I was talking about if you're using the push model, you don't need to have that schema like on the right or in that registration, because that's part of the service discovery itself. So yeah, so in this mechanism, you essentially have some set of scrapers that you can actually partition by maybe sensor ID, as you're saying, like, and maybe those scrapers are getting and pulling the data from the defined interval time from the sensors itself, like reverse. So that's what I understand about pull model here.
So for pull model, like, my understanding, like, it was not related to the sensors, but then for the viewing service. So suppose a request comes to view the data for, like, what is the minimum and the maximum for a particular day. So instead of pushing it somewhere, like, on a UI, so whenever the need is there, we just pull it. So my thought process was regarding that model. So that is what I called as the pull model. Something which is not real time.
Yeah, Kevin, that's what I was thinking, like having like a slash matrix that can you can actually put the data. Yeah.
Hey, man, so I need to drop off, but I can share the notes with you and the group. If you guys are still online in like 30 minutes, I can rejoin.
I think like if there are no more questions, we can drop off and we'll take the feedback offline, or like we can join again sometime later if required. Is that fine with everyone?
Yeah, yeah.
MindPixel, just one question. Is this
Mhm.
a premium whimsical account, or